So we are on to problem number 5 of the MIT Integration Big Qualifying Exam 2012, which is the definite integral from x equals to 0 to x equals to 1 of the sine of the arcsine of x. So it's a nested problem, but all the same, very interesting. Let's see how we're going to be able to solve this. So our problem is the definite integral from x equals to 0 to 1 of the sine of arc cosine of x dx, which is interesting. So as the rule of thumb tells us is look for the most complicated part, and for me it's this arcsine expression here, and what I'll do is I'll say let u be equal to the arc cosine of x, which means that cosine of u is equals to x, and that means that when we differentiate with respect to x, so we have sine u negative du dx equals to 1. That means that we can substitute for dx with negative sine u du, right? So that's an important expression for us. One other important thing we'd like to do is let's look at the x domain, let's look at the u domain, the limit. When x is 0, the arc cosine of 0 is, what is that? The cosine of 0, using this expression here, is pi over 2, and the arc cosine of 1 is 0. So what that means is that our problem in the x domain is the same as we have 0 being pi over 2, 1 being 0, then we have sine, and then here we substitute this with u, and then in place of dx we have negative sine u du, which means that we now have negative 0, this is pi over 2, 0, sine squared u du. So one important thing is when we have this negative here, we can always flip the limits and that negative disappears. So we have 0 to pi over 2 of sine squared u du. And then, I mean, this problem now becomes fairly tractable. We can use the expression cos 2a being equal to 1 minus 2 sine squared a, such that sine squared a is the same as 1 minus cosine 2a over 2. Using this expression, we can now say our integral from 0 to pi over 2 of sine squared u du is the same as the same problem with 1 minus cosine 2u over 2. And then we can pull the half out, and we do have now our problem being half 0 to pi over 2 1 minus cosine 2u. So this is a half. Integrating 1, that becomes u. Integrating cosine 2u, that becomes a half sine 2u. And then we have our limits. As we can see, both at the upper and the lower limits, cosine 2u, sine 2u, sine 2 times 2 pi, sine 2 times pi over 2 is pi, sine pi is 0, sine 0 is 0. So essentially what we're left with here is just a half pi over 2 minus 0, because this goes to 0 at both limits, and this becomes pi over 4. Because so this is what this problem required of us. Until next time, I hope you enjoyed this solution. Bye bye.